What's up, guys? Um, I am going to do lesson 6.3 for you now. Um, and I thought I would put a little camera of myself up this time, mainly because um, working from home is interesting. And one of my children could pop in this room at any point in time, and I just thought you might find it entertaining. So here we go. Um, so we're going to do a warm-up first because I want to make sure we really understand the series and sigma notation from the last lesson. And this lesson I'm going to teach you today is going to be learning a little bit more about sigma notation. So we got to go back and make sure we understand what we've done up to this point. So in the last lesson, I gave you three different formulas for finding the sum of a bunch of terms. And so one of the formulas was A1 over 1 minus R. Another formula was, let's see, N times, whoops, try that again, times, no, okay, 1 second. Don't know what this is here. What is going on? Okay. Maybe I'll have to write in a different spot. Another formula was, oh Lord, now I'm all flustered. N times A1 plus AN over 2. I might have put over 2, just put N over 2. I can't remember at this point in time. It's 9:30 at night, and so my brain's not working very well. And then the third formula was A1 times 1 minus R to the N over 1 minus R. So these three different formulas, and we use them all in different situations. This top one is used for an infinite geometric series. This second one is for a finite arithmetic series. And then this bottom one is for a not infinite, finite geometric series. Okay, so I have three different examples here. We have to choose what kind of series we're looking at, whether it's arithmetic or geometric, and then we have to choose whether it is finite or infinite. So this first one, you're going to start with this part of the question, and you're going to look here, and you're looking for a format. When I say a format, I mean either an explicit formula format for an arithmetic sequence or for a geometric sequence. So geometric sequences have an explicit formula format where you have A1, you have a common ratio, and then that common ratio is being raised to a power. And usually that power is n minus 1, but essentially being raised to a power is kind of what we're getting at here. And that power is changing. That looks like what we have here. -3 would be A1, 0.9 would be the R, and then the power is changing because the values of K are changing based on the summation. So this would classify as a geometric series. And then the next question is it a finite or is it infinite? Well, this number up here tells you where to stop in a series. That has a value that is not infinity, so that is a finite, meaning it has a clear stopping point. So then we will be using this third formula to find the sum. And essentially it's like the sum of the first, actually 30 terms, because 0 is the starting value. So I would want to find the long way is I would want to find all 30 terms and add them up. The short way is you use the formula. Okay, so we're going to use the formula. And in the formula, we need to know, what is it, 3 different variables. So in the formula, I see A1, and A1 is located right here. So that's -3. I see R right there. And I see N. And N is going to be the number of terms. Okay? Now this is kind of a trick question in this problem. N is how many terms are you adding up? So if we start at 0 and we say we have the 0 term, the first term, the second term, can you see this? The third term, the fourth term, right? If you're counting with me, I have one more term than where I'm currently at as far as n equals 1, n equals 2, etc. So even though this has a 29 at the top, k equals 0 as our starting point rather than k equals 1 adds an additional term. So we actually have 30 terms in this question. And once you find all those 3 values, you can just plug them into the formula to find the sum. So we would have the sum of the first 30 terms would be equal to, let's see, -3 is A1, 1 minus R is 0.9 to the 30th power over 1 minus R. And we're going to grab our calculator and we're going to type it in. Okay, and again, when you're typing in, I would suggest that you do it in chunks. So like I just typed in the part in the parentheses first, and then I'm going to times by -3, and I'm going to divide by, what would it be, 0.1. And my answer is approximately, and I'll round this, but -28.728, rounded. Okay, moving on. Next example is not in summation notation, but we're going to write it in summation notation for practice because, you know, why not? Okay, remember, a sigma symbol means that you're just adding up a bunch of things, which clearly we are because it has plus signs between terms. You can pick whatever letter you want. K is used a lot, N is used a lot, I is even used sometimes, which you'll see more examples of that today. But you can pick whatever letter you want. I don't know, I guess I'll stick with K because that's kind of what we've been starting with. So we'll just say K equals 1 means start at the first term and then add up until when? Well, this has ... so we're going to keep going to infinity. And then here I need to put my explicit formula for this sequence. It is geometric. You can tell that this 8 is being divided by 3 and then divided by 3 again, or timesing by 1/3 would probably be a better way to describe that. So our common ratio would have to be 1/3. And then our A1 value is clearly 8. That's the first term. So I'm going to write my explicit formula saying 8 is A1 times R to the not n minus 1. I will be using K this time because I just decided to use K. And then as far as formulas go, let me go back up. We are looking for an infinite geometric series, so we're going to use this one on the top, A over 1 minus R. And then A, we already said A was 8 over 1 minus R is 1/3. I don't need a calculator this time. 1 minus 1/3 is 2/3. And then you can go outer inner. So outer inner would be what, 24 over 2, which gives you 12. So the sum of all the terms in the series to infinity would be 12. Okay, last example. So this one says, add up all the terms from the first term all the way to the 275th term for this thing. Well, you'll notice you don't have an exponent, which automatically means it's not geometric. This one is arithmetic. Arithmetic is something that's just like addition, subtraction, or maybe even multiplication in the explicit formula. Okay, so I think what would be more helpful in this example is if we write out a few of the terms, because it's not real clear like what these numbers actually mean. So I'm going to write out a few of the terms. And remember, the way that you do this is you just take the starting value, in this case is 1, and you plug it in to the formula, and that'll tell you the first term. And so if I plug in 1, then that would give me what, 7? So 7 would be the first term. I'm going to go ahead and plug in 2 because it would be helpful to see what the next term would be in this sequence. So if I plug in 2, I get negative 10 plus 12. That gives me 2. And then maybe I'll do one more term. So I'm going to plug in 3. That would be negative 15 plus 12 is what? Negative 3. So then this is representing a pattern that starts at 7 and then goes to 2, negative 3. Okay? Now, is this infinite or finite? It's finite, right? Because it stops at a number and not at infinity. So our formula is going to be this middle guy. Okay? I'm going to write it again down here so we've got it close by. This one says that to find the sum of a finite arithmetic series, we would have n times a1 plus an over 2. All right, do we know n? So n means how many terms are you adding up? We do know n. N was 275. It says it right here. Okay, that's good. I really think I might have put divided by 2. I'm trying to remember, but I'm going to write it this way now. A1, do we know that? Yeah, we found A1 because we just plugged it in and found that value a second ago. And then AN, I don't know if we talked about this a whole lot in section 6.2, but AN in this case means what would be the last term that you're adding. And so that would be the 275th term, but what's the term value, okay? So I would need to plug 200, why does it keep doing that? I would need to plug 275 into the equation to find the value of the 275th term. So it is negative 1363. So that would be your A sub n value in this problem, negative 1363. All right, got everything you need, just compute. I would do parentheses first, of course. So that is going to give me negative 1356. Right? Yeah. And then I guess I could maybe divide by 2 first and then times by 275. It doesn't really matter, I guess. So I am getting negative 186,450.